At first, school,
Hey guys, how's it going? We're doing some vertical distances between graphs, and we're going to try to create expressions that could give us the vertical distance at any x. The first three questions, yeah, you can find this. The key to finding vertical distance is to understand the y at the top. I'll say the distance is the y at the top minus the y at the bottom. Well, let's say if you plug in 1, this is y equals negative 2x. You should know that when x is 1, y is negative 2. When x is 1, y is 5 here. What's the vertical distance between negative 2 and 5? You'd say it's 7. Cool. Well, I could also just say, well, here's an expression for the distance at any x. The y top equation is y equals 6x minus x squared. Like any point on this is an x comma 6x minus x squared. Any point on this is an x comma negative 2x, which means the vertical distance between these two graphs at any points is 6x minus x squared minus negative 2x, or plus 2x, or 8x minus x squared. Now look at this. When x is 1, I get 7. Look at that. I have a distance equation now. What's the vertical distance when x is 2? Well, you could plug into here, and you could plug into here, and you get 12 minus 4, which is 8. And you see the distance is 12. That's 8 minus negative 4. You got 4 and 8, so you got 12. Or watch this. Plug in 2 here, and you get 16 minus 4. That's 12. Look at that. What's the vertical distance at 3? Well, 24 minus 9. What's 24 minus 9? 24 minus 9 is 13. 15. 15. 15. Let's double check. 3, negative 6. 18 minus 9 is 9. 3, 9. 9 plus 6 is 15. Great. So it works. But look at this. I can understand through my analysis of this equation how x equals 0 and x equals 8 will be locations where my distance is 0. When will my distance be a maximum? Well, let's think about the graph of this equation. This equation is a quadratic. We know we have zeros of distance. I'm going to graph distance. Zeros at 0 and 8. My distance is 0 at 0 and 8, which means at 4, I must have a max distance. So my distance at 4, plugging in 4 into this, is 32 minus 16, which is 16. Cool. So like we found we were getting close to the max distance. We got 7, 12, 15. The max distance actually is 16 at 4. We would have seen that the distance decreases. What's great about this is that like you're not guessing and checking. You're knowing for a fact. This is the answer. This must be the answer. You don't have to check any decimals before or any decimals after. If there was an answer that was a decimal, boom, you'd be able to get the answer. Okay? Okay, we got 3x minus 6, and we have x squared plus 2x. I don't know which one's which. It's like the line doesn't have the x squared. Boom. And we want to go straight to the vertical distance. So I got an x, negative 3x plus 6, and I got an x squared plus 2x. To find this vertical distance, I want the y at the top minus, let's be careful, the y at the bottom. Now, when I subtract x squared plus 2x, I'm going to be subtracting x squared and 2x, which means I'll get negative 3x plus 6 minus x squared minus 2x, or I will get negative x squared minus 5x plus 6. Cool? Let's use your expression to find the distance at 0. Okay, well, the distance at 0 is 6. That's so easy to find because I just plugged in 0 into my distance equation. But you could also check this is 0, 6, and this is 0, 0. What's the distance at negative 1? All right, well, I can just plug this in here. I'll have the opposite of negative 1 squared minus 5 times negative 1 plus 6. So this is going to be negative 1 plus 5 plus 6, and I get 10. All right, let's find the zeros of the expression and find when the vertical distance is going to be a maximum. Well, I'm going to have to factor out a negative so that I know, okay, yes, I know how to factor this. Two numbers that add to get this and multiply to get that. That's going to be x plus 6, x minus 1. And the two numbers are going to be at 1 and negative 6. So when I graph my distance, negative 6 is a 0, 1 is a 0. I know that it's this negative x squared graph. My distance equation is negative x squared minus 5x plus 6. I know that in the middle, because of the symmetry of a parabola, I will have the vertex. Where is the middle? Well, what's in between negative 6 and 1? I can find the average, and I get, negative 6 plus 1 is negative 5. Divide that by 2. Or if you go from negative 6 to 1 on your x's, you add 7. If you want to go halfway, you'd add 3.5. If I add 3.5, I'd get negative 2.5, or I'd get negative 5 halves. Bam. There it is. Now, what is the distance? Well, I'm going to probably need a calculator for this. The distance at x equals 2.5 is negative 2.5 squared minus 5 times 2.5 plus 6. Let me get a calculator. All right. Negative 2.5 squared. Negative 6.25. Minus, parentheses, 5 times 2.5, close parentheses, equals plus 6. Why did I get a negative value here? Oh, because it's negative 2.5. My B. Start over. I'll have 6.25 negative minus, parentheses, 5 times 2.5, which is negative 12.5, which I add is positive 6.25 plus 6, which I get 12.5. Cool. So like that is not something you'd be able to figure out. Maybe you could start guessing and checking and hoping it's at the middle, but I don't know, it's harder. All right. Negative x squared's open downward, positive x squared's open upward. So this y at the top, this y at the bottom. Simplify, subtract, and add. I'd get negative 2x squared plus 4x plus 10. Use my expression to find the vertical distance at 0 and at 1. Well, at 0, I'd get 10. That's easy. At 1, I get 10 plus 4 minus 2, which is 12. You could also double check that. If you plug in 0, you get 10. If you plug in 0, you get 0. Great. Yep. So I have 10 to 0 is 10. If I plug in 1, I'd get 9. If I plug in 1, I get negative 3. Plugging it into this equation to get negative 3. 9 to negative 3 is 12. Great. Find the zeros of your expression. Okay, we need to somehow solve this equation. I'm going to factor out a negative 2, and things get complicated. We cannot factor. There are no two numbers that multiply to get this, multiply to get this and add to get this. So, heads up, we have to use the quadratic formula. Now, what's great about the quadratic formula is the following. It shows you the symmetry of a quadratic. Let me show you. Let's just go back and know that we can't factor and use the quadratic formula. Quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, 4 times negative 2 times 10. 4 times negative 2 is negative 40. Wait, 4 times negative 2 is negative 8 times 10 is negative 80. All over 2 times a. Okay, so I got the opposite of b plus or minus the square root b squared minus 4ac. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Great. 16. 4 times negative 2 times 10. So 10. Okay, great. So I get x equals the following. Negative 4 plus or minus the square root of 96 over negative 4. Why do I love the quadratic formula? Because watch what I can do. I can split this up into the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. Why do I need to know this? Because this has to be the center. If I'm adding and subtracting a distance that is the same distance, this must be the location of the vertex. So in the quadratic formula is this idea that this, negative 4 divided by negative 4, must be the location of the vertex. 96, what goes into 96? Is 36 going into 96? No. 4? 4 and 24. 24's got another 4, so 16 goes into 96. All right, root 16 root 6 over negative 4, which is 1 plus or minus 4 root 6 over negative 4. This becomes 1 plus or minus root 6. Many of you are not sure about this. We'll review the quadratic formula. We have been reviewing it occasionally, but right here, when will the distance be the maximum? At x equals 1. X equals 1 will actually be the location where the vertex is the maximum. X equals 1 is the location of the vertex. This plus root 6 would be 1, 0. This minus root 6 would be another 0. If you want to think about it, and if you don't understand this, just watch it again or come in and I'll give you a problem before school. We have 1 plus root 6. We have 1 minus root 6. 1 must be the location of the vertex. Okay? And that's the idea behind the quadratic formula. X equals 1, the distance is 12. Wins. All right. Peace.